Casey Kingstrong here on the scene of the crime. The crime of how many people will be enrolled in medical school by 2019, the year I will attend medical school. I'd like to throw it off to our reporter, Casey Kingstrong, who's on the scene of the crime. Casey Kingstrong here at the scene of the crime. I would like to begin by talking about what exactly I did and why it's important to me. So, I used information I found on the American Association of Medical Colleges website on how many kids and students have been enrolled in medical school each year. I used this information I found on the AAMC website and graphed a linear model and found a equation of best fit, and it was linear. I then used the equation to predict how many students will enroll in medical school in 2019, the year I plan on attending medical school. This subject matter is important to me because ever since I remember, I've wanted to be in the medical field, specifically anesthesia.
She needs help. She may be too proud to say it, but how about we don't let this patient die and give her a hand in?
I've had a huge interest and a lot of curiosity in the fact that I myself am able to predict the number of people that will be in medical school the same year I intend to. Now I'd like to throw it off to our other reporter, Casey Kingstrong, for the results. Thank you, Casey. And I'm Casey Kingstrong here with the results.
And there's a 30% chance that it's already raining.
Along with that, I began by making a scatter plot, a graph of the information I found off of the AAMC website. My x-axis values here represented the years of 1998 through 2012. My y-axis represents the total amount of students enrolled in medical school per year. My domain and range of the function is all positive real numbers, and it assumed that the total number of people enrolled cannot be negative. You cannot have a negative amount of people enrolled in a school. And we also can assume that the information and the data is not going to increase forever, because eventually the population will stop, and it's very unlikely the entire population will be doctors. The function increases pretty steadily, as you can see here, with a slope of 247.13 people per year. A linear function best models the data, with an R-squared value of 0.9286, which makes me even more confident in my data, because an R-squared value close to 1 means it's a pretty dang good fit. There are no maximum or minimums because it is a linear function, as opposed to a quadratic or quartic function, for example. On my spreadsheet, I made a table of the real life and predictive values of the total U.S. medical school first-year enrollments using the best fit linear equation. What I found as a general observation when comparing the two tables is that between the years 1998 and 2002, the predictive values underestimate the real-life data, which is highlighted in the blue. Also, between the years 2000 and 2012, as you see here, the predictive values underestimate the real-life data as well. Here, highlighted in the orange, means that the predicted values overestimated the real-life data, which I found was very interesting, being that it underestimates overestimates, and then underestimates again. Here highlighted in the yellow is the predicted amount of students that will enroll in medical school by the year 2019. That is the year that I intend on enrolling in medical school. What I found is that by 2019, approximately 20,593 people will enroll in medical school along with myself.
Wobble baby, wobble baby, wobble, yeah. Wobble baby, wobble baby, wobble baby, wobble, yeah. Wobble baby, wobble baby, wobble baby, wobble, yeah.
The day I won an all-expense-paid trip through medical school. In 1999, the Dean of Appleton Health Medical School, also known as AHMS, the school where every person in the United States that gets enrolled in a medical school attends, hands out a full scholarship every 5 years to one student who accurately completes a challenge during Welcome Week. It's 2019, and I'm enrolled at AHMS, which means it's the 4th anniversary of the challenge, and I can participate. All the students gather at an assembly to hear the dean reveal the challenge. The dean gets on stage and begins to explain the challenge. He explains we have 2 hours to predict how many students have been enrolled to AHMS this year. The student with the closest prediction wins the full ride scholarship. The number has not been revealed to anybody except for the dean. By the looks of the assembly, it looks like there are tens of thousands of people here. The dean explains that we can use only paper, pen, and a calculator. The dean starts the clock and gets off the stage. The crowd is going crazy. Everyone is trying to head count each person and are running around in havoc. I assumed this would take too long, and I decided to slip away from the chaos and walk around the building to try to figure something out. I have to get this scholarship. My parents are not helping me out, and I have no money.
Help me, I'm poor.
Unlike a lot of these privileged people.
Should we smile? Shopping, dancing, bottles, tanning, shoes, credit cards, boys, selfies, cars, clubs, lunching and friends, jewelry, partying. But it's really important to spend within your means. People label me as manipulative. You're my poor friend. Just because you spend money doesn't make you a bad person. Oh my god, it's Crystal. Yeah. Have you ever partied so hard you parted your eyebrows off?
Rich Kids of Beverly Hills.
While I'm walking around, I spot something that may just help me. In a hallway, I found what looked like a large display case of medals and trophies. In the display case, I also find a plaque that has labels of each year since 1998 and the number of people that were enrolled in AHMS. But the problem was, they only had information until 2012, before they ran out of room on the plaque. I almost turn away when I remember I can use this information to find a best fit equation to help me predict the total for this year using the graphing calculator we were allowed to use. I immediately put all the information in the tables in my calculator. I put the years in the X with 1998 representing 0, 99 representing 1, and so on and so forth until I reached 14 for 2012. I then put the total amount of people enrolled in AHMS in the Y because timing the X works out very well. I graphed the information on my calculator, changing the window to better fit the information. Wow! The enrollment has increased steadily each year, which must mean the total enrollment must be more than 2012's enrollment of 19,517. But I'm stuck on finding a consensus prediction. This is when I remember back to my senior year in high school in my CIS math modeling and prediction class. I remember that I can use my calculator to find a line of best fit and the equation to that line to help me predict this year's enrollment. I use my calculator and try each regression equation to see which function fits best with that data. But how do I know which function fits the data best? Think, Casey, think. That's it! I remember my math teacher, Mr. Febreze, once said,
Eliminate odors and reduce allergens with new Febreze Allergen Reducer.
if the R-squared value is close to positive or negative 1, the function is a good fit. I tried each function until I tried the linear function. Cool! The R-squared value for this function is 0.9286, closer than any function I tried. Which means the best fit equation must be linear. I used the equation and graphed it with my scatter plot, and it matched almost perfectly. So I used the equation of y equals 247.13x plus 15,403.
What the hell did you just say?
Y equals 247.13x plus 15,403. That was best fit to predict how many people are enrolled in AHMS this year. Well, it's 2019, so I must use 21 to represent the year, and 20,593. That's it. That is my prediction of people enrolled this year. Oh no! There's only 60 seconds left of the challenge, and I'm all the way across the building.
Ain't nobody got time for that. Ain't nobody got time for that. Ain't nobody got time. Ain't nobody got time. Ain't nobody got time for that. Ain't nobody got time for that. Ain't nobody got time for that. Ain't nobody got time. Ain't nobody got time. Ain't nobody got time for that.
I quickly write my name and predicted number on the piece of paper and run to the assembly. There's a big bowl where everyone writes their prediction with their name on a piece of paper and puts it in. Five seconds left. I'm almost there. 4 seconds left. Ouch! I tripped over someone. 3 seconds left. Move! Get out of the way!
Get out the way.
2 seconds left. I'm almost there. 1 second left. Boom! In the bowl. I made it on time. It takes a couple of days for them to read each ballot.
3 days later.
It's the day they announce a winner. I'm so nervous. The dean gets onto the stage and speaks to the assembly of people about how close of a call it was. I guess the winning number came down to just one number difference. They call out the real number of people enrolled at AHMS, and it's It's 20,594. I haven't stopped repeating my predicted number of 20,593 for days, so I immediately get excited.
She is now Ellen DeGeneres.
But then, I remember the dean said the winner and the second place person was only one number apart, which means someone could have gotten it right on the nose.
Your case is worth
Vladimir. He was one of the people who head counted each person. He was running up to the bowl at the same time I was. They announced my prediction first of 20,593, and everyone begins to clap in amazement. But they haven't announced Vladimir's yet, and his face is bright red. This could either mean he won or lost. I have no idea. My palms are sweaty. I'm so scared. They announced his number, 20,592. What? I won? Oh my gosh, I'm so excited beyond belief. This is when I realized he was 2 people off because I wasn't in the room. I was in the hallway, and he forgot to count himself. I chuckled softly. Everybody begins to clap and cheer, and Vladimir runs out of the room crying. I go onto stage and accept my scholarship.
Jennifer Lawrence. Silver Linings Playbook.
This is the first Academy Award and second nomination for Jennifer Lawrence. She was previously nominated in this category for Winter's Bone.
Thank you. You guys are just standing up because you feel bad that I fell, and that's really embarrassing, but thank you.
What a way to begin medical school. The